Oh, no. Hey, so can you hear us online? Yeah.
Okay, sorry. So we'll start with the easy one. So at the last summit, or not summit, GA meeting in Boston, this question of sort of sending deltas came up. So we wanted to give an update, talk through sort of just the experiments we've done. Sort of we got to a proof of concept, and then everybody got busy, as people do, and so we just wanted to sort of quickly walk through it. Okay, so just for everybody, so this was actually brought up by So in particular this meeting, but it's not something that's new. Graph South suggested something about this in 2018. You know, So came up with it. Geometry Jim had done some work, and I had done some work with Quantic. But so there's been versions of how do you do deltas on the existing schema, so 2x3, IFC4. And so we sort of just did a review. This is actually slides from the first meeting we had just to walk through the sort of stage setting. So ArchiCAD has actually implemented something like this with Celibri. If basically to cut to the chase, you add header information. The header information helps you understand what's changed. That's basically all we're proposing to do. So we sort of have gone through versions of these. There's a basics of this is changing must be calculated from the authoring app. There's no sort of magic happening with the IFC library in these sort of discussions. The resultant IFC file is sort of, it can have some loose ends, let's put it this way, given what we can do with this approach. Now I'll jump into the frazzled by my stupid laptop here. But at the end of the day, what you'll see, what we've spec'd out is just the notion that we can, as long as we provide a model starting point, the version of the model you're going from, and the elements that are changed, you can add these together, but you'll get some noise over time because you would have things that relationships and these sort of things that we don't have a good way to prune as you add these up.
Yeah, we can go over kind of the details later when we start talking.
Yeah. So we've sort of agreed on how we encode this. I'll show what we sort of looked at. How we handle deletes, we figured out. The extensions we punted on, and basically we'll talk through that, and basically not covered. You know, we're not sort of going any deeper in anything beyond just here's the updates, add, move, or basically anything that's new or changed and delete is only scope. Everything else is sort of beyond that. So what we actually came up with, this is basically all you need to do this by putting it in the header. So you have the model ID, what's the source model that I started with? So the full-fledged export, what's the ID of that model? Then I need the version of this particular one. So, you know, I need an ID on the update, and then I need to know the predecessor. So this predecessor could be the same. If it's the first delta, the predecessor would be the main model. But if you're like the second, third, fourth, what have you, you need the predecessor because they have to walk in order. That's the limitation of this sort of simplified approach. And then you need a sort of comma-separated list of, or array basically, of deleted items. So it's basically the file content is updates. This gives you deletes.
And that should be global IDs,
Correct.
to use the proper term.
Okay, so these are the
yeah, sorry.
character.
Yeah.
Yeah. So I wrote this, so I always get things wrong. I'm an architect, but a building architect, not a software engineer. So actually, I think this is what Angel came back with. I think, right? Or no, either you or Posse came back with. So this is basically the summarized version of what this actually looks like.
In Revit.
What's that?
Not everyone would have a Revit model do it.
Correct. Right. This is but this is far we got. We have a proof of concept that we ran internally with the header in the wrong place. So I can show you a video of that later, but it's not all that interesting. You can imagine what's happening here. There's a lot of problems with this approach. It probably makes the most sense in the consumer CDE context. Design transfer or like moving from design application, this gets quite messy, but like the use case we were targeting was going into Solibri and piling up a bunch of updates, and you could show history over time or another model paper. Questions about any of this?
Can I ask you a question? Why are we putting this in the IFC file itself instead of a change management system external to that?
Point to one. I mean, we don't have a standard one.
Oh, I don't know. We just, sorry, but no, I there's so many of them. Kids. I don't know. It doesn't matter.
IFC is awful to get because it's unordered.
Right. Okay.
I can't do because it's line number. So
Right.
you put a IFC file, the next version is, but you can't compare it very easily.
Well, hang on, so let me make sure I understood your question. Was your question, why don't we just have a Git version of every IFC file? You can see the delta that way. Or was your question, was that your question?
Well, so if you put this is what, right? That number moves, I mean, the contents move.
Okay, so these additional files, or these change files, if you will, they have all elements of the same ID that they had in previous files.
So in my mind, and I've got a bunch of questions for the group myself. Well, there are a couple of reasons for this. One is performance, right? I don't want to re-export everything every time. Sure.
Yeah,
Export can be.
This was by far the primary use case is export speed. It's just like some larger, no matter application, it could take an hour plus to generate export from an authoring application.
Yeah, especially in a client server architecture or something. This could be a big deal.
And import also, right? If I get, here's your delta, then obviously I only have to process the delta instead of everything.
Sure.
So performance is a huge reason. If you do have change management or change tracking software, obviously you just made change tracking software's life a lot easier, right? Knowing what the change things are.
You never have a file change really because you're just adding files all the time.
Right. Well, if you had, well, there are a lot of change management systems that work with IC, right? They just say, here are my old goods, here are my new goods. You know, here are the missing ones, here are the added ones. And now I can look at all the geometry that's changed or properties too, right? If you had a Delta file, you would just say, oh, you've just done my work for me, right? I can much more easily say, here's what was in the file, and just show that.
Okay.
So those are work cases, which I think you need to verify with non-HOK people. But that's certainly, we know of at least one person or one company who would like that. But that's, I guess that's the question. So I'll leave it at that.
Yeah, I mean, the only way this is possible is currently is if the authoring app can maintain UIDs and version history of changes. You can do post-processing, and otherwise, if you're doing post-process, this is a moot point. But if the authoring tool can, and we know ArchiCAD and Revit can, but the request is the same across both. So I don't know, you have a question, I'm gonna stand up here.
You're saying this is state of the art, so there is an update coming, a different way coming, or?
Well, so this just came up in August. So both myself and John Merchant at Geometry Gym had started working on this when the Revit version became available. So, but it wasn't a question, but someone like Dassault wants to consume these updates, doesn't want to have to consume the whole file every time. They just want to consume the changes. So this is why it was on the table, and I think this came up.
It kind of brings up kind of an interesting scenario though, because I know several agencies, DOTs that I've talked to and worked with over IFC, they see IFC as a potential way to archive projects. You know, not trusting that Bentley and all the disks will survive forever.
Yeah.
But they look at it as an archive. So there's going to be a version of the IFC that they're going to save it to. Sometimes the project is archived, it's never been built. And they come back years later to when they get funding, to reinvigorate this project and start over again. You know, if they use IFC as their archival system, then this becomes real important to them. If they were, say they were a Bentley state in 2020 and 2032, they're, you know, some other cat software came along and this makes both ideas. Yeah, I've got funding, by the way. No.
So the key thing about this is not a hack, but this is far from perfect.
Yeah.
This approach
But-
for the deltas, let's say.
But I mean, you know, if it's a 5-year-old project and they were going to do it inside initially, and they decided to go outside to a consultant because the consultant may use a different product than what they did their initial design in.
But
So there needs to be enough information in there for them to know what version and how to reconstitute the models.
I would think for archiving, you would not use this at all. Right, so,
Well, I told them don't use IFC for archiving, but they just, I mean, you know, DOT's paranoid.
no, I meant, you would not use incremental. In other words, I would think for an archive, you would say, I don't care how many steps I've done in the past, start from scratch, give me a file, it can take 5 hours, doesn't matter, it's for the next century, right? I would kill all the increments and say, give me a full from now, right? So this is really a project that's on the go, right?
Okay.
continuous development is, so like for a design firm, we might do export daily. Construction sort of for a deliverable to a construction company might be weekly. So what this is trying to solve is how do I not spend hours of processing time versus minutes? And so then somebody can consume that in minutes. So that's the general use case.
But I agree, and again, some of the questions I want to discuss here are around scoping, right? And so I think one of the things that you say is outer scope is you can if you want, but that seems silly. Like, I wouldn't want to store 100 Delta files for archiving. I want to store the archive.
Right.
I'm assuming branching and merging is out of the scope as well.
Yeah, this is sort of a linear approach.
So every Delta release should accompanied by a full, like your release, and then you say what's new. So the two should live together.
Because this won't give you change history, it will give you changes from the last state. And so if you need to build up like an original plus 5 incrementals, you need every incremental in between to get to the current state.
And actually, I would say branching isn't necessarily out of scope. There's nothing here that says, like if you had a base and then you said, okay, I'm going to go down this path, and someone said, I want to go down this path. That's fine. Okay, I can view this file, goes this path, and this file.
Oh, yeah, individual branches maybe it's fine.
Right. Now, I think it'd be, someone would have to manage that. That would be beyond the scope of this little Delta file.
But not reconciliating them. Excuse me, not reconciliating them.
No, right.
That's out of scope. Like concurrent editing, it's out of scope.
It's a graph.
Yeah.
And you wouldn't merging is out of scope.
Okay.
I was gonna say,
That's right, it's a tree.
this model currently supports tree-based version. We could extend it later by making previous model version IT support multiple to turn it into a DAG, right? But for now, we can do, like, I mean, it's not perfect, but it's better than what's there.
Correct. So that's why we agreed we try to do this, because it seems relatively straightforward. If the scope is, I have original, I can guarantee you I'm going to give you the sequence, and you have to play back in order to get to current state. You know, if people are comfortable with that, this is really all you need to do it.
You could come and play in the bidding process to get our dinner.
Yeah, I mean, there's all kinds of reasons why, like being able to do this quickly and small pieces of information is good. It's just, it is not a global solution to all change management.
But there's an excellent workflow there, right? Like I had an initial bid. Now I want to modify that, and I want to understand what the modification is, right? As opposed to having to manually
Mhm.
figured out.
Recreated.
Yeah. So my biggest question at the moment is, what is the atomic unit of model ID? Meaning, can I start my project, I make a wall, I save it. I make another wall, I do an incremental. Or is that the granularity we want, or is it okay to say, no, it's, you have to save before you get a delta, or some other, what is the finest grain we want here? Because I mean, model IDs aren't necessarily something that you would create constantly, right? You're not necessarily creating a model ID every single time a person moves mouse cursor.
Oh, I mean, so knowing how your software works, I'll ask it for you. Is this an on commit export or is this on change? And my assumption based on how we use IFC today is you can't get it out without having saved your work. So you have to have committed your work in the native tool before you can export.
I mean, that's my question, though. I don't want to assume that that's correct.
But basically the options here are continuous change, which no tool I'm aware of works this way, but we should point that out. That if I keep moving a wall, every time I move it, it gets a new version GUID for that element. Or version GUIDs only get updated when I commit the data to its central storage system, and by doing that, I get a new version GUID.
I think it's kind of sad that we haven't defined it backwards. Right, because right now you need the source data and then you can track the changes. What if we have the target data and we can track what changed to get there? Because then you can actually go back and forward.
Yeah, but so this, I mean, what happened in between could result in creations and deletes and never show up at the end state, right?
Yes,
Right, so if you have only the,
you would have a journaling data.
There's also the optimization aspect of it, right? Like, I can, if I have IFC file A and I have IFC file B, I can always generate a delta J.
Right, if it's like that,
Yeah,
yes.
I mean, right. Anyone in this room, any coder in this room could probably very quickly say, give me 2 IFC files, I will generate this delta. You've already done all the hard work of generating 2 full IFCs, right? The interesting thing here, at least interesting in my mind, is how do I quickly generate this delta? Right. Now, for the change tracking, like that's a workflow that maybe doesn't matter, performance doesn't matter, right? I have, building 2.0, and I want to know what changed from building 1.0 to building 2.0, and then you say, okay, this delta format lets you transfer that information after the fact. I will, as you say, create a delta based on existing information.
Right.
But having said that, I have a previous IFC file and my model has moved to 2.0, and now I want to quickly generate that delta. That's more kind of interesting. Now maybe what you're saying is maybe that part is out of scope. This really just defines, here's what it would look like. I don't really care if you find out how to do this super slowly. This is how we communicate it.
yeah, I mean, there's so much you want change to have to do in this, but like realistically, you run into problems like because of how graphed IFC is, changing a level name probably makes you want to just generate a random file. Right? Because most systems would update everything connected to that level. And why just at that point, change it, export a random file. I mean, because most internal design systems have this sort of graph that thinks that way as well. So like calculating changes that, but just the level change, everything else connected to the level did not change. I don't think we'll find if we did a survey of the authoring tools, that level of specificity.
I think conceptually, I'm kind of, to me, this looks like it fundamentally wants to be a snapshotting or committing based system to start with, because I've never designed anything or watched a designer who made something and, oh crap, gotta erase that and restart. And now if you're publishing these commits, you're just generating boatloads of data that's ultimately useless. And so instead, it's like in this thing, maybe internally the systems, they can build up a cache of every change if that's appropriate, but at the end of the day, you've got a linked list where all you care about is the head and the end, and that's what gets shipped out. So from like an interface contract, the snapshotting mechanism seems like the most direct. Whether if a system chooses to build up a bunch of internal state capturing the changes, but all we care about at the end is what happened from here to here. So that was the question, right? I mean,
Yeah.
Can anyone think of a strong, compelling argument the other way, why it really would be beneficial, or why it would be pragmatic to have? Because I can say internally, like some of these other systems that do real-time changes, they move really quickly.
Sure.
Well, you can imagine, why would anybody put IFC in the context that's currently used? Why would I ever send anybody? I moved this wall 6 inches or 100 millimeters, then I moved it back, and I moved it again, and then I moved it back. And then I put it back here. You'd never send them that noise. You'd only send them an instant.
That makes sense to me. But it doesn't, I think it needs to be stated explicitly, right? Like, this works for, however you want to use a generic term for a saved state of your model. This is not intended for real-time capturing of your deltas.
In code for usually. You also have granularity there, like some coders say, push, and then have this one commit that then they choose themselves. I think there's something to be said for knowing who did what when, but you don't need to know all the mistakes they made to get there.
Yeah, and this will be, because I think both systems don't know who did what, when it changed to. So like getting that in IFC is also difficult, but. So, okay, so let's take an whole statement, and basically if we say that this is a sort of transaction is the right word? Commit, what would we like the word? What's I did some work and then I saved it. That's when I can generate this thing. The end of, what do we call this?
He calls it a chain set.
Western Bullswood?
I don't know if we have just one. And it's not a snapshot, because a snapshot represents a full state capture. So it is a delta. A commit is the reason it's only. So I don't know, again, terminology that they come up with what that is.
Yeah.
A saved state. These can be generated at a saved state from the authoring application. Is that fair? Words.
Right, it's easier to just know what you don't need, what you don't want, than to do want. I think it would be said, I think saying something like that, right? Like this is not intended to be a real-time increment. It's intended to reflect whatever vendor action results in
Committed work.
Right? That's
Change set is a fairly evocative term for it.
It's always associated to an export task, right? So it's not, I'm building my model in my tool, I save it. I change something and I save it. That's not enough. I need to export to get these additional bits, right?
well, the thing is that exporting to IFC in any of our software, I believe, can be done at any time, right? I create a wall. This project is nowhere. It's just on my computer. I export to IFC, that's legal, right? But you wouldn't be able to then create a new wall and incrementally export that because there was no, this doesn't even have a file name yet, right?
Because the limitation is very much like you could work in VS Code or something like this, but unless you commit to Git, it doesn't have an ID. View it, right? Like It's not there until you commit it. And so the same limitation exists in most design softwares, is that it's not gonna generate new GUIDs unless you submit a change bit of data to then react to it and assign new change IDs. So that's why, like, this version ID sort of thing is at the element level, it's a necessity that you've committed it to whatever authoring tool. You have the UIDs and then you can export.
And this is a side note, but as we look at IFC5 stuff, is there an opportunity to strengthen or refine if we're using these GUIDs? Like, do we want to ensure there's a total ordering on these, so you could potentially reconstruct some extra forensics? Like, let's say I have a set of deltas. Is there any hint the system could give that maybe I'm missing something? Like, I can clearly see I'm missing a backlink, but at least I could put them in some kind of sequence, or do we just stick with randomization like we have now? And that's probably a separate conversation for the future.
If you don't stick with randomization or GUIDs, then the problem is, are they really globally unique still?
Well, there is like UUID 7, which is totally ordered, and
Totally ordered.
you know, but again, that would be a change in the spec, you know, that we have to make in the future to further strengthen something.
Yeah, and I think some of the people, the discussions around IFC5 just want ledger, so continuous.
So probably separate.
But
Very good
there's
point.
a reason why both topics are in the same session. But, okay, if we were to say that you have to have committed this internally to your design application before you can have an expectation of exporting a delta. Does that make sense to everyone? We have to document these things.
Hang on, because now there's a corollary to that. Okay, I've saved my project. I create a wall. I export to IFC. Now I create another wall, I save that and do the delta. But my original save was actually a marker, right? It was a marker plus a wall. So does that mean it's not a valid initial stage?
Yeah, I'm very confused. So the save is that, when you say save, you mean save to native format?
Yeah.
Why is that even related to this?
Because of the GUIDs.
GUIDs are the same as the related, okay, interesting. I didn't see that being.
There's a GUID that's going to be associated with your model, right? The model itself.
The model of the native file.
Yeah.
Okay, yeah.
Like that's what lets us know this is where this comes. Well, I mean that's right. There's a previous version. Well, I mean, okay. There's the model of GUID is not the model version.
So I
the
think
previous model version ID are the two.
We're conflating model version versus the ability to calculate change internally in the applications. So most of this, what Angel brought up, is the limitation that most applications won't give you new UIDs to indicate a change unless you've committed it to the application.
Yes, more generic. Like so again, let's forget the model GUID. Right, it's really about the model version ID and the. If in Bentley you had to generate a version that's associated with a particular stage,
Sure.
how often is that published?
It should be defined by your publish. You say, it doesn't matter how many times you save in your native model. It doesn't mean you publish. You publish this IC and you deliver to your downstream. And then you do 3 days of work and save 1,000 times. But now you think you're ready to publish the next version. That's the delta should be provided between this IFC published and the next IFC published. It should not count into how many times you saved in the native model.
Right. The question is simply, how is that version ID from published A to published B created in a consistent way?
Yeah, I consider like a gate, you have label.
Right, but because basically what we have really just two things we're trying to parse here. It's like, I made this wall and why can't I draw this? Option one is I made a wall, or I made a room, and now I just want to say, give me an IFC. I have not saved. Option two is I make the same wall, I save in my native application, then I publish. That's what we're talking about.
Well, and I'm saying that that save should be inconsequent to your export to IFC, that the version that you're using in the IFC should be IFC related, not.
So you are correct from a functional standpoint. Angel's asking me an expectation question. Angel's tool and ArchiCAD can only give you change detection after you hit save.
Well, that's based on that tool specifically.
Right, but it's an expectation question. Should you be able to do it here, or should you be able to do it here? Thus far, we only have tools that do it here. So should the expectation be you have to do that?
You're gonna get a lot of problems if you're really asking people to save and then basically you cannot export anything you haven't saved.
Correct. That is a limitation that this system.
You cannot incrementally export.
Well, sure, with this mechanism, you can't export anything that.
You can do a full export at any time.
Right. That said, no one, I can't tell a reason why you'd ever do that, export something you haven't saved.
Oh, I don't know. Don't ask the user to be limited.
Right, but we have to think about the context of IFC, right? IFC is an exchange format.
Right.
Why would I'm gonna do a bunch of work and not save it?
No.
As a user,
Yes,
it would be a
Yes,
what
you
if
do.
statement.
yeah, you do work and not save it.
Well, I understand that, but I wouldn't share it with anybody. Because this is an exchange format. This is this is not a technical discussion. This is the only way we can have this work today, and otherwise we just stop the conversation, is that we have this limitation.
Well, so the problem that I have in making this work for me is that in ORD, for instance, it's automatic save. It's basically a file that is saved continuously. So if you're now saying that when I export to IFC, then and take the version of what we don't use that that way. Now, if I say iTwin in a Bentley, then yes, I totally agree with you that we have a published workflow and that there's change sets and that we already have a change management on top of
Right,
that.
so if you say this a different way, are we okay with, if we cross out the word save and by the word publish, do you expect the user to have saved before they publish?
I think you are correct in saying that right now, IFC is a published format.
Right.
So the act of putting it in an IFC file is a publish.
Correct.
From my perspective. So that's why I'm saying you should almost have a GUID associated with your last IFC export and then compare it.
And that's what we have a requirement for. It's really just, let's be blunt, we can't, no one could do any of this today.
Right.
Unless we assume this is a published workflow versus a live workflow.
Versus what workflow?
A continuous export live. Or uncommitted, unsaved, or unpublished.
I don't think that's a reasonable way. Like today in Git, you have a release, but you based on the data on your local build, it never commits into the hub. And that's not, you can do that, but that's not a reasonable way and to release your product. You have to, have something basically merge, right? And then you say, this the label you
Actually,
release.
merge is the right word. So it's are we comfortable saying the limitation with this workflow is that it's a part of a published merged workflow? We don't have to get the language, we can write this out and people can agree to it after the fact. And again, this is a short-term solution to build on top of IFC 2x3 and IFC 4 plus.
Yeah, right, because it's right, the question I'm trying to figure out, we want to write out this header, right?
Yeah.
So let's forget the model item, that's
Sure.
whatever. And I can obviously create a GUID on the fly for this model version, right?
Yeah.
How about the previous model version?
Well, you'd have to remember what you're comparing it to, or since when you're tracking your changes.
Right, so you have to remember that, right?
Yes.
Which means that either it's in your current state, or it's had to be been saved. Right, so if I,
No, well,
No.
that assumption is incorrect.
okay, so how do I know? I open my model, I create a wall, I export. I don't save it, I close it.
Right.
I open my model, I create a wall.
You now made a branch.
I would say you make two, you make, those don't have the same root.
Yeah.
Right, so what?
Well, I mean, the first save was also predicated on a root somewhere on the model. Now, the second one, if you open, now you need a branch.
Right, so the point is that that model version ID was saved as the previous at some point.
I'm still tracking with one problem. This requires existing state in order to track the change. And if I'm understanding your point, is that meant someone had to, either the system or the user had to initiate a state capture that lets you know what the previous GUI.
I think that's I'm
Well,
that's
because
going through my head. I think that's, I can't figure out how not to do that.
Well, so I mean, I built one of these on top of his platform, so let's explain how we had to do it, so maybe this helps. So I have a version 1, I export. You can either externally save the current, the state, or you use the IFC itself. So John Merchant's tools and Geometry Gym, what they do is they write out, show this differently. So they put the, this is the IFC, they put the mod version 1, they put it in there. So when you do go step 2, you ask this one, what was the ID you had for that version of the model? And that then gets populated into the next export. So you have the, mod v1, and then you have mod v2, because you were able to ask the last version of IFC what it had as its version ID. So you actually use the IFC file to store the ID. When you export, you ask it, what's the version you had? And I'll ship that forward as the previous version.
Right, and that's fine.
Right.
As long as there is, you have to do one of two things, right? Either you then have to load up that IFC file, so you know, here's where every element was.
Yep.
And now I'll do a delta.
Correct.
Or you have to say this ID corresponds to this state that I can generate from my native file, that I can get from my native file so that I can see the delta from that, right? There needs to be some correspondence somewhere, and I don't see how that exists without some sort of commit,
Correct.
I agree.
right? Unless you say, okay, this isn't here, yeah, I'm gonna read the whole last IFC file and I'll fit delta that way, but that seems to, well, that certainly kills the performance aspect of it, but
I think you're living in a world where your native format is very much close to the IFC format.
Mhm.
That's not a published workflow that I usually have, where the native format is way more contrived and complicated, and that becomes a mapping exercise. So it's a real true publish. I feel like that makes this harder.
Just to make sure I understand, you're saying within your tools, I think I heard you say a few minutes ago, a lot of the saves are automatic and transparent to the user.
Right.
So,
They're atomic.
so, but even, that means there's a eventing that's going on inside the engine of this thing.
Yeah.
And if we imagine a little man in a room inside the Bentley product just hitting save every time that event's triggered, what's the functional? Like, couldn't you capture those events and just, have it generate this list automatically? Instead, because in all these
But
other
this
systems.
list That's my point, like I can get to a model here, and I can see the change set in my design file. But I cannot relate that one-to-one to change sets in the IFC file. So I can't make a generator that says, okay, just for the changes in the last 5 minutes, I would like to generate an IFC file. Well, just because it's not that one-to-one mapped.
So changes, right? So let's be clear what changes or what the expectation is. Because I would expect that the expectation is they have 3 sorts of changes, or 3 sorts of actions: add, change, delete.
Sure.
Right? And at least for version 1.0, I would expect that add and change would write out the element, your entity element, would write out your change code. Presumably you have some concept of an entity in.
I do, yes, like they're design entities,
Yes.
not publishing.
So the design entity gets exported to IC.
No, the design entities do not have a corresponding design entity. No. We have, no,
Did I create a wall?
let's start with walls.
Pick the simplest thing that makes sense from an architectural.
Simplest thing that makes sense, what breaks the sound.
Column, a beam.
So, like, let's take an alignment for a minute, right? And the fact that there is a horizontal part and a vertical part to it, and I change a point, right? Point is an element inside Carpinteria.
Yes.
But it's not an element inside IFC.
Right. If the point is an element that is part of an alignment.
Correct, exactly. So,
But is the point associated with an alignment in Batman?
yes, but the alignment is based at, is built up out of multiple elements, etc. It's like, it's not a, there is a mapping.
Yeah.
But it's not a trivial one-to-one mapping, and that makes this complicated, that's all. That's why usually when you're saying, okay, here are the elements that are changed, for instance, in a DGN file for open rows. That doesn't make it so that I can say, okay, well, I have to only run this algorithm on these elements over here to generate some other elements that I have to change the IFC file, especially not because the IDs here are not the same as IDs over here.
Right. So what you're saying is it's difficult, given a set of entities that have changed. It's difficult to know what level is actually the changed thing in IFC. In other words, I've changed this point.
Yeah.
It's difficult to know, okay, that point happens to go up to become part of an alignment, and that's the thing that would have changed IFC.
Correct, exactly, yes,
Okay.
yeah. Just because the concepts are different in IFC than they are on that design file.
So you can only compare when you export it to an IFC.
That's right, so then the simplest way to do this would be to export the whole IFC file again and see what it changes, and then do the change it. Which would eliminate the performance.
Look, sounds like you have the same problem with Civil 3D, and that the civil side is attaching grids to those sub-objects, which would then solve that.
It would defeat a whole kinds of memory performance issues that we solve otherwise, yeah, I mean, you can't attach grids to everything.
But you could, right. Presumably though, if you said, okay, I'm going to export without export. Right, I'm going to go through and say, okay, let's pretend I'm making it.
Yeah.
Right. So now I get to the alignment.
Yeah.
I say, okay, alignment, what are you made up of? I'm made up of all this stuff. Have any of you changed? Yes. Okay, I will export. None of you changed? Move to the next.
Yeah, but I think the issue is like when we get into corridors and cross sections,
Uh-huh.
right? We may have 2 miles of roadway section.
Yeah.
And we have thousands of sections
Yeah.
and thousands of points. And now our problem is we're doing all this check, and since the roadway doesn't have a very good ISC format, we then end up with just a vast amount of data that we're processing.
Mhm.
That makes the delta just, you're recreating a new file for the roadway.
Well, I mean, this is sort of the case of all infra with any change to section of IFC.
That's right.
Right? So, I mean, maybe we can make the hell out of this. This only works for buildings-ish. I mean,
Unless we change the workflow for civil products.
well,
or
this
transportation.
is like, these are the considerations for IFC 5 where we need to make sure you can change one thing, not everything.
Well, I think this works great for IFC to IFC workflows as well.
It's actually implied in the specification, because every state is based on an IFC GUID. So it means every state in transition has to be kind of a full graph of IFC changes. There is nothing that's right. That's kind of implied by what's everything here.
In fact, there is a question about what do you define change? If a containment for the related object can't change, do you consider this space
Oh, yeah.
size is changed?
So this is where this IFC is not very good for this. So the only thing that this solves is speed of export and if you're willing to limit some noise. Because it doesn't solve 90% of what you're describing, because yeah, most substantial relationship triggers will change a lot of elements in any not native authoring tool. So this is not a panacea for anything. It's just, are we comfortable saying with probably works good for buildings, you have to have committed this data before you export it for this to be a valid workflow. And by the way, here's a bunch of other caveats that if you want to use it, you can. That said, a lot of the current users of IFC probably would benefit. So that's the.
You mentioned that people had implemented this conic and geometry gym. Do they have working implementations that they're happy with, or are they just experimental at this point?
Well, so Quantix is actually a post-processing version, but the one I built on top of Revit and the one John Merchant built on top of Revit, they're functional. They need to be sort of, and actually, ArchiCAD's version with Solibri has been functional for a while. Just that hasn't been public knowledge. So.
In John's version, though, if I understand correctly, actually does build a full IFC every time. It just only does incremental work to do it. Right. So he takes the old IFC, rips out what's no longer there, adds what's new, changes what needs to be changed to replace the new one.
It's just an implementation choice. Like, if you want to send somebody a delta, you want to send them the delta. But if you want to just, I'm doing it for myself, and I just want a full IFC file of John's implementation, geometry gym just does that all in one step.
Right.
Delta
it is the most dangerous of them, though. Right. Because the delta is quite clearly what it is. And if I had a full, I would hope that it would be guaranteed to be the same thing I would get if I started from scratch. In his case, that's not true, right? It's in fact almost certainly not going to be the same thing you get started from scratch. Hopefully it is conceptually the same thing.
Right.
Right. And by the way, I'm not dissing on John's work, I made it, right? So but I would think that that one you'd have to be the most careful with. If I kept incrementally updating my IFC file, I might have weird noise.
Well, so from an implementation standpoint, we should basically say that because this has potentially irreversible effects, you should keep the original delta. And if you want to make a merge, you make a merge.
Right.
You don't get rid of the original delta.
Right.
And just another point for making sure I'm tracking is that we were talking about points a few minutes ago, but implied in this workflow is that everything's got a GUID. So the only things that are tracked are descendants of IFC group, right?
Yes.
So those points actually wouldn't come into the conversation for this change tracking, right? It would be just anything that has those are not captured in the.
Yeah, this is like property sensitive.
Right. In version 1.0, it is not so atomic. Right? Like you could imagine that version 2, 5, 10, which would say, I'm a wall. The only thing that changed was my mark parameter. Right. So I'm only going to send you that. Or right, 1 point out of my 1,000 different defined points. But that's what will be on the scope of 1.0 later. If anything changed, everything gets sent. I mean, figuring out the Holy Grail is what I just said last, and maybe that's something that IC5 will.
So we should move on though, because we need to get going.
I had one question. There was initial slide where we had the owner history.
Yeah.
Do you know in the case of that whether it seems like this is a question that
Go forward to one more. There you go.
this is a question that relates to me from this is a question that relates to me. In the case of owner history, it seems like it's one shared value across all the objects.
there is owner history on every object, but nobody uses it.
And that's it, or it's separate.
Actually,
Or.
these guys do. This is the only implementation I've ever seen that they do object level owner history, but I don't think anybody else would know how to do it.
Or does you hope that you have at least 30, right? You added the change, or 2, I guess, added the change, right? Because that at least would be more accurate than now with most Delta releases just added, that everything's that.
I mean, I think every file I've ever seen owner history is just the date file is exported.
Well, the point is that you could, at the most dumb, right, would have, here are my added things, here are my changed things. You probably want to have at least those 2 other.
Yeah, it is a question, do we, I mean, does owner history come back into consideration? Because I think most people want to get rid of it.
Yeah, you're looking at me, right?
Well, you're smiling.
Yeah, I'm happy to get rid of it, because if nobody supports it, then the conclusion is that it doesn't.
Well, but
But again, it's not my call.
So the question is, do we want to actually say, as Alan Hall suggested, you actually use owner history, not for every object, but the collection of objects to say modified or added. And that's, but it doesn't help you. 'Cause
Yeah, you don't need
the
it,
whole
you'll
file I
know.
have, the whole delta I have would be added or modified.
yes, I'm saying you could, and by the way, I'm not saying you should, because I think you can figure it out anyway. You could say, here are the added ones, here are the changed ones, right? There's 200 histories, everything is either added or changed, but you probably figure that out anyway. When you loaded it.
Yeah,
and
I
said,
don't have
"I'm
this
using
ID,
this
I do
field."
have this ID, I know this.
Yeah, the use cases.
Right, so I agree that it doesn't add much, maybe it would help for some sort of view, right?
It might have a meaning outside of the file name, like it might have a meaning to some kind of state of the project, where this is a modification that I'm applying or something like that.
Yeah, I don't think we have anything written down that allows you to add a commit message to the header or the file itself. I mean, the infrastructure is there. We've never decided how to use any of these things. Okay, so we'll not say we're gonna get rid of owner history, but we're not gonna say we're gonna use it. Okay. Okay, let's move. Appreciate the time.
You're switching topics now, right?
Correct.
Yeah, just one comment or maybe question on this. Because we've clearly identified the use case where you want to do smaller exports to just speed up things. But this then really only works on one model, right? You have an update of one single model, one file. We haven't even spoken about.
Well, there's no federation. This is
Yeah, exactly.
one file from one authoring tool, moving
That's
through time.
perfect. Just wanted to
Not
have
like-
that on the records.
This file, that file, no, this doesn't work great.
While you mentioned it, it's all the more reason to pause on anything more with owner history, because
Yes.
it's the ugliest kludge, in my opinion, you meet on your way down the IFC tree, and it entirely implies this kind of linear development cycle.
I couldn't agree more. This is actually the perfect reason to go to IFC5. However, we've scheduled a coffee break somewhere
Okay.
as well. Do you? No, it's up to you.
Well, what's our time limitation?
We have a reasonably hard stop at 5.
So, I mean, 4:50.
That's a coffee break.
The Democratic Organization.
Yeah.
What's the next topic? Next is the next topic.
IFC5.
Yeah.
IFC5 is the next one.
Yeah, that definitely requires.
Yeah.
10 minutes? 3?
Well, we did say that IC five was gonna solve a lot of problems.
We just don't know how.
Exactly. Okay, 10 minutes. It is currently 3 o'clock, 3:10.
Yeah.
So 3:20. Okay, so this is a pretty meaty topic, so the way this will work is I'll try to go through the sort of requests of the format. We've already stumbled upon half of the ones you run across, or not half, some large percentage of the ones when you start to look at IFC 4 in its current state. Devon will then give us a presentation about some of the research he and others have been doing, which I've been involved with a little bit, around how to feed a next-gen solution and let you go from there. And then we'll come back to a little bit more, trying to get into the weeds, but I doubt we'll get too far of what we think pieces of this look like. So let's just get started. So requests. So you can read, but I'll just sort of highlight the big ones. A lot of them have to do with distributed, centralized, federated. So simultaneous work, you know, it was brought up that in the civil or the infra space, you guys aren't doing a lot of design build. In the building world, it seems like that's all we're doing, which is continuous overlap, you know, give us some early information, update, update, update. So, you know, having distributed smaller information, we get examples like this, you know, sort of additive workflows. So on the UK Road Authority, I know you're going to build stretch of road. I'll give you the IDs for those signs. You populate the signs, give them back to me at the end, round trip the data. Combined with other data, this is a big one, especially, well, it's from everybody, but you see it in rail, being able to connect to geospatial, other management systems, change, and then I've added this, but it's not a request that we've not had before, which is sub-element geometry. So don't have to think about a whole element, I think about a piece of an element. So I will skip this. And then the other is, along with being able to represent different geometry, being able to represent it in a way that's maybe not step. So GLTF, OBJ, some of these things are not geometry formats, but just the notion that the value of IFC is not how it's encoded, it's how it represents information of the semantics. And so we should be able to extend beyond that. Also, we had the discussion about time. This is IFC today, but it really, you know, basically invalidates every previous step. Really needs to be more like that, not stuff we haven't talked about. Multiple owners. So I drew a light bulb, but I made a light fixture when I drew this. But basically this idea that this little object has potentially, you know, this scenario, you know, an architect owns a location, lighting designer, electrical engineer, contractor wants to procure it at the same time, and maybe it's actually the attic stock that you're updating from a existing building. So like this circle points out that there's a bunch of different owners, different points of view of the same data. So the idea that a wall and a door could have, like this door in that wall could have one meaning to an architect. The lintel and the wall and the door has a different relationship to a structural engineer. The control system on the door has a different meaning to an electrical engineer. I'm an architect, so I default to architecture situations, but these are very similar things with like a rail system that has a control network that sits next to, you know, sort of the track control system versus the signaling control. Then we have, I just need 3 versions of the same thing that are different representations. I have a space, I need a net area, gross area, and I need this volumetric one for an energy model. 3 different representations, same data. We'll skip design transfer because we'll come back to that. And then some of the more advanced requests. I put into this advanced user developer sort of views is, why is IFC so deep, and why is the sort of, you know, historical C++, how you manage the code base built into the data structure? That's a commentary. You get this really sort of deep structure, and really it's a hangover of making it easy to manage the code, manage the standard. So everything inherits down. But if you look, now that we started adding stuff, I found an example where void inherits from element, but then you have to get rid of it if you're talking about a non-building element now, because we're doing these things where you're adding non-building stuff in there. So it gets really silly. Flexibility in repeating stuff. You know, I have a little example that talks about the complexity of that. Libraries, this business logic is sort of similar. And then making it easier to represent in different forms of storage, random access, security, and machine reading. I guess we get three. This is Dion's list of, we got this list from him this summer. So it's a very good list, but we won't go through it. We're not gonna go through it because I've summarized the high points, but there's just a lot of sort of big things in there. And this is David de Koenig's list, which there's a lot of repeats. You know, this one is a newer one, multiple organizations. This makes perfect sense if you know, you're a rail operator and you have buildings, but I think about my rail yard being horizontal and the building sits in it, not everything sits in the building or it sits in a different spatial structure. So organizing the spatial structures differently. So that these two are actually the very same thing. So being able to have different hierarchies for the data. This is an interesting one. He doesn't mean that you shouldn't be able to find change. It means you shouldn't try to make a change detection system out of IFC or whatever this new system is. So can I easily find change, but maybe not built in, like say hashing, pick a hashing algorithm, pick it and throw it in a scanner. That's not what he's suggesting. You guys can read the last. The slides will be available. I'm trying to be efficient about this. So the grouping one, I'm a user of IFC, and then I know enough to look at it when I want to make a point, and it's always fun to look because you find things that easily make a point. So what I was trying to find is a good example of this grouping clustering topic. So in IFC today, and somebody like Angel or others keep me honest when I lie, but I think this is true. If I want to share properties on those 4 chairs, I use type. If I want to share geometry, I use map. So now, right now I have 2 concepts to sort of link those 2 together. If I want to say that's a collection of things, I use group, but a collection that's not a collection used for placement, just a collection. You are a member of this group, sort of like a system. If I, for some reason, want to think about this as an asset, I use the subgroup called asset. And if I want to think about it for inventory, I use the subgroup for inventory. Which for me doesn't make much sense because these are just different forms of group. I understand why there's names on them, but the distinction here is minor, if not insignificant. Now, if I want to think about placing them, I can use this element assembly that can be used to place objects as a group. And it can defer to the element geometry being placed, or it can have its own placement. The second you do something like this, like throw that says like, what does it actually say? A charger in this table, you've basically blown up all of IFC because now this is not part of buildings, it's in the distributions, like the electrical distribution system. And I can't tell you which one of these, but it still works. So to me, and then lastly, if you want to use a novel form of placement, like, what is the word we have in here? IFC reference, which is basically added when we added the alignment to put stuff along an alignment, then this is a completely invalid object 5 different ways because this placement falls outside of shared building element scope. So this is sort of like when we talk about IFC, this is why there's a whole lot to look at, not just like how we represent it. Like this sort of historical kludge is what we have to address. Questions on any of that? I mean, anybody disagree with anything I've said? Anybody? How many people use map? Do you use map?
Yeah.
Okay, it's hard to know. So, but the point is, like if we need to solve a problem like this, where, you know, one view of the world looks like, you know, this rail network plus a building, all of these things need to be revisited because you need much simpler concepts to be able to assemble data in a more aggregate way. You need to be able to put it together in different storage formats. Skip through that. You need to assume that, skip that. And I need to assume that because we're adding complexity and what we're starting to describe as a system where we need to break things down into smaller pieces, we're going to need a system to manage those smaller pieces. And so I'll skip ahead a little bit. And then finally, this last thing that even though IFC is a standard, no one wants to call it IFC. Basically is what we're seeing. Like we had a meeting in Zurich this summer where a lot of this stuff, they actually want to call it a federal wall. That's what wall is in their nomenclature. They want to be able to define it distinctly. You know, there's different bins for a product template. There's several different ways to define a beam. We don't really support named concepts very well that describe these things. And I'm just going to skip ahead and get a little bit further, and then we'll pass it on to Devon. Sorry, I'm going fast. I'll pause for a second. Anything that not makes sense right now? Besides, I'm skipping things.
So far you've only shown what's wrong.
Correct.
Okay. And everything makes sense.
Okay. So, somebody, you already invalidated my learning from the web because this is not from the web. This is learning from technology stack. But what we've been trying to do for a long time is sort of make IFC the transport and the definition. And I think we've been failing ourselves there. So what we're looking towards is a system that is agnostic of IFC and tries to make it transport first. And then separately, we put IFC inside of it. Because if we need to solve IFC, GIS, other data, we need to sort of think of this separately. But IFC is obviously going to be the first sort of test case. So what we're looking at is I'm sorry, this thing is getting cut out. This is ECS-like. So ECS means entity component system. So I'm using the word like now because there's a couple traits. So any component system comes to the game world. Basically, it means you don't have full objects. You take objects and break them into pieces and assemble them as needed. So we're in an object-oriented view in the world. This is one wall. In an entity component system, well, it's a location, a property set, the geometry, something else. That distinction, pretty straightforward. You could say no.
I mean, data-wise, they are kind of depending on how they are described to me. So on the left, I see a class definition, I guess, and on the right, you see a bunch of subclasses with relationships. I mean, what's the difference in data structure?
Primarily the left-hand side, if you look at the criticisms from the earlier section that people were bringing up, a lot of it came down to the rigidity of, I give something a name, you know, it's an element until I suddenly it needs to play a different role in another circumstance. A lot of we get hamstrung a lot because by putting things into a rigid, especially, you know, single inheritance hierarchy, like a typical class structure, everything is it's a mammal and it lays eggs, and then suddenly you end up with a platypus and you got all kinds of issues. What is on the right-hand side is basically saying objects and assets in the built environment play different roles to different stakeholders at different contexts, and that a lot of the criticism we're seeing is pushing to move towards a more compositional model, which you don't
So you're
get.
getting more flexible.
Yeah, and it's fundamentally a compositional model. So a beam can have attributes tied to it that are not part of its initial class definition. And more of the use cases are pushing towards that compositional based structure, which is what's on the right.
Or one entity owns properties and someone else owns geometry.
That's all well and good, but that means that it's less restrictive, which is your selling point. My point is that makes it harder to make extent.
And then that's a key point we have to talk about. It's if we open the doors to this compositional model, what does model completeness and validation look like? That's
Right.
big, and so that's one of the things we.
My beat could look like a red.
Right.
So this is why Devon is here. This is the word I used for this is not a good word, so we should transition to the work you're doing, because this exact question points to a much more defined level of control, or not control, definition that's easily shared. Like this particular problem, like if we break it apart, we need a better infrastructure to define these things and make sure those definitions flow through a whole
You
process.
just moved your problem. Right. Just moved your problem out of your language definition into some other thing that you haven't come up with.
But you've changed the dynamics, but that doesn't mean that there isn't a steady state that we can find. I think the community as a whole is recognizing the rigidity of the current structure is not meeting the needs collectively. So the question is, if we begin to explore more compositional models, one, what new opportunities does it open up? But two, this isn't like the gaming world where, I can just go ahead and compose a bunch of things and I'm updating the location of all the spaceships. I need to know on this date that this team actually has all of the information on it. How do we address that? That's one of the things I wanted to talk about. But just as the gut check, does the general thesis that we need to support this kind of different stakeholders contributing and composing information onto these assets as opposed to having everything defined in one place makes sense in this kind of federated hybrid view that Greg was talking about.
So I do want to make one distinction here, because I think it might be similar to, when you look at the definition of IFC wall, to be honest, it looks a lot more like the thing on the right than the thing on the left. Right? You actually, the thing that's static is there are 6 arrows, right? You already have these sets, or sure, there are 4 arrows, right? Where it falls apart is, number one, there are only 4 arrows. And number 2, what happens when you make a tunnel? Well, now you have to have IC 4.4, right? Because there's no tunnel concept. A system on the right allows you to expand without needing to create new structures, right? That you can cross out the word wall, put the word tunnel in there.
But can I check first if you're talking about the same thing? Because when I see this, I kind of have the impression that you're trying to talk about an IFC instance, like a file. And we're not talking about the definition of the standards. Are we talking about the definition of the standard, or are we talking about the composition of a file?
Talking about the composition of individual objects within a file. So
Yes.
if you were talking about this thing has a GUID, and I can associate a bunch of information to it. The structure of those chunks of information, those components I'm attaching to it,
Yes.
would be standardized by buildingSMART at the top level, and
Yeah.
kind of like we do with PSETs today, potentially with some room for extension. But it's all attached to the same.
Exactly. So the comparison here is that on the left you have this monolithic thing that is now an IFC file. You have a wall with a lot of components and geometry, and it's all locked into this one container. And the idea is to move that towards something more flexible, where also others can add a piece on top of that.
So this is yeah, okay, then I was confused. Because it looks like you're saying that there is, on one hand, there's a definition of a wall that's more constrained than on the right side, which is definition of walls.
Yeah, I think fundamentally,
The constraints need to be set in the specification, and that is still the same on the left and the right.
Okay.
yeah, it's whether these are 4 separate concepts that associate with wall versus one concept that associates with wall that includes all these things.
See, but that's, again, doesn't have anything to do with where it's stored in the file. That's everything to do.
I'm afraid it is. Generally, when you look at how things are being stored in a file, it's very difficult to break them apart. PSEPs are.
They don't even have units. PSETs don't have units.
Yeah.
Like, you can't have because of this, everything I hear from Root, everything that doesn't have a unique identifier, like, their geometry doesn't have its own unique identifier.
Geometry definitely does not. Property sets do,
That's-
properties don't.
That's interesting, they don't in BSD.
He said,
Yeah.
probably doesn't.
That was one of the things we had to work on.
So, like,
Properties, you know.
Like, that certainly doesn't have its own ID, that doesn't have its own ID, that, I guess we think does.
The P set does, the properties don't, yeah.
But a concept where it has an ID in my mind is only useful if it is reused or referenced. If it's only one element that uses it, what is the point of the reuse?
Because it's owned by other people. So you want the architects to own the wall, and you want the fire engineer to own the properties, the fire properties on that wall.
So I had this was a dumb presentation I put together to explain how we self-design transfer, but maybe this illustrates this better than every diagram. So let's say I want to have the most simple furniture layout software in the world. And what I want to do is use that piece of software to lay out furniture. Okay? Simple concept. So today, what I do if I want to move from one application to another is I export 9 chairs and I give them to the next application, invalidating that one. Because basically I have to give complete control, because I have to give the whole chair to that application. So if you think about this, like I can't give you export from one application and give you just the location. I have to give you the whole chair.
So you're saying you're moving the source of truth from application A.
Right, but so I have to invalidate this one, or I just have 2 copies. Those are the choices we have right now. Given this, a chair is a fixed object, complete definition is in the chair concept. Versus, actually what I'm doing is, if I look at this model, what I'm exporting is a chair entity 9 times with maybe a style, a location, and a geometry. Okay. Now, if I give that to the next application, I have it reference it, so it can attach to that same entity. It can copy, create, or map a relationship, and can add some new information. So now, if I export from both applications, what I have is potentially some redundancy, because most applications we have more capability than just bits of information, but I have style, location, geometry from this one, location, properties, material, geometry from that one. So this, I'm showing 2 applications. This could be 2 users and using the same application, but have different tasks. And so by breaking into pieces, what you're able to do is assemble the representation that's necessary for whatever you need to do. So I've taken these from those 2 buckets of components, and I can make a whole.
What are these 2 files, or are these 2? I mean, how is this separate?
To make this assembly, I have to assume I can put them in one container, whatever that means, file, database, whatever. We have to say they can exist in the same world for the time being. You can use file if that helps.
But the concept is that there's an object that has a filler, which is in some sense the only thing of it that's actually unique.
Right.
And it
Sure.
exists outside of any application.
Okay, so like a template or an inventory of possibly a chair or something like that.
Right. So this blue thing is just chair, I have a GUID. That's it. But that is all that you need. If you have that, basically you can do this collection of these different pieces of definition to it. Instead of having all the information in this object, each one of these components has discrete information that maps to that chair.
Okay, to be specific, this is column, right? A column is generated, and that's a conceptual thing. A structural engineer gives it its structure, right? So that attaches some geometry and some material information. An architect attaches the finish, right? It's green. Structural engineer could care less what color it is, right? Just install the roof. An electrical engineer comes along and attaches electrical outlets to the conceptual thing. The electrical engineer could care less what color the column is. The architect can then turn it to red and nothing else changes.
And it's flinging the whole thing back and forth to each other.
Right.
You're enriching and annotating it because you have this GUID is the tieback. So anyone anywhere can say something about that thing without needing to have it. We have a production service that basically took the piece at concept, has these GUIDs, and implements a workflow, very similar to this. And one of the really interesting things to watch was how teams, especially different subcontractor groups or different design subs, were starting to coordinate with each other and contribute information without having to kind of fling the models back and forth to each other or all use the same software. As long as I have the GUID of the thing I'm enriching within my tool, I can contribute just a little chunk of information or retrieve a little chunk of information I either need or am responsible for just with that little hook. And that was, they were telling us that was a really useful flow because otherwise they're having to take the whole wall and move it over and do a bunch of editing and then move it all the way back.
The electrical engineer might need to know that it was junk.
Yeah.
And where this gets more powerful is when you have to move across contractual boundaries. So let's say I've had this chair, and like I said, in the building world, we're seeing a lot of simultaneous workflow. I send the chair, the location, geometry, and the properties to, let's say, a contractor, and they have some furniture procurement app. They insert a product that they're actually going to buy, cost, and their procurement process. This side of the equation doesn't need to know about it. They can be separate, but if you sort of play this forward, we did something trivial, move them, you replay this, there's a change, the location's updated, here you go, here's version 2 of the locations. They didn't lose any data. We segmented the data in such a way that someone can control locations. One of the early attempts we had at modernizing IC to sort of make it flow like this was to break it apart into individual properties. That's not a concept, but like these components are composable. So the idea that location is a logical concept, and there could be many types of location. buildingSMART has to standardize. Linear location, sort of different forms of these things, but there's still stuff you have to standardize, but they're discrete parts of data that some person, entity, part of a, sort of a project company can control. And this is why sort of conceptually breaking into this smaller chunks makes perfect sense, but we should switch to Devon because the commentary that this just makes a lot of smaller pieces, conceptually, it's the same pieces that we have to control today. We just are looking at making them smaller. So,
yeah, and we can transition though, but Greg, I want to just check for what your take is on this. Like this move here, I think is a big piece of where a lot of work has been going. So getting validation or real kind of digging into this thesis is important because there's a lot of stuff that derives from this that we just want to check on. We started this conversation maybe 6-9 months ago, so it's been floating around for a while.
yeah, the terminology, like I've been working on this for a long time, but the ECS thing was the first time we actually got some clarity about what we're talking about. So that's June-ish where I learned about this term, but then we started talking about that. So yeah.
And there is some complexity here, right? Like there's an assumption that you can add these things that somehow are independent of each other, but in reality, there can be dependencies, which, for example, I move the location and now that ottoman is inside my wall, right? And so this particular chair needs to be a chair without an ottoman,
Yeah.
right? So-
Well, and to get this level of sharing, components have to point to their entities. Entities cannot know about components. So we need another structure on top of it that you can do some normalization if you want to ask entities for all the components. These are the sort of problems you run into, but they're worth solving because this is basically the root problem of most of the trouble we have with IC today. Two things, just when I'm saying that. One is ownership has to be a whole right now. This is saying you can have one entity own material and one entity own a property. 1 or 10, doesn't matter. So that's, ownership is a big deal. And then the other is, back to the conversation about change. If we only know about the whole chair, we can't even hope to have a change discussion if we're sending the whole chair versus actually changing the locations.
You introduce a new relationship if you put the placements into a kind of a components.
What, like relationships as they stand at IC in the sort of express world, I have to be completely rethought because you start to want to give them names, not just functional names, just like the components, because what you start to realize is that the power of a system like this comes from the relationships, but if you just genericize them, it's a problem. So we should pause there and not go too deep on that one because that's another ball of wax. But to Devon's point, does this make sense of how you'd solve a big hairy problem of collaborating on a multi-owner, when I say owner, multi-author data set that has to change over time and be augmented?
It makes sense, but what happens if I'm the owner of the chair entity and I delete it and then recreate a copy because I did it on accident? How do I then propagate that down to all the other software in the file?
Yeah, I mean, that's a good one because there almost is no owner of the entity, really, because it's just a pointer. So like that's probably the real propagation problem we have. So is it, one of the things that was on the earlier slide was this sort of approach wants to be immutable. It's only a copy add. It's not update. So to that point, is it, I'm really just telling you, I don't have it anymore. I'm not telling you to delete it because I want to give you the, like, if you're the, let's say the contractor, and you added this information to those chairs, you don't want me to send you an update and it just deletes that data. You want an opportunity to rehome it, remap it.
And to Greg's point about layers, this is really just a foundational, what's the meta model that we're kind of containerizing the stuff we're sharing with each other. It doesn't itself imply a specific kind of transport or exchange system. You could do this in a way like what we have today, which is, at Trimble, which is a fully centralized, everybody on the project has to talk to this one center thing, but it could just as well work with a distributed, that's kind of a whole separate layer. So one of the things here is to break this pretty big problem down. If we align conceptually on this as a data model for containing and holding on to the information, then we can begin to address, okay, we've got these things called components and they're tied to these goods. What are the kinds of workflows and exchange processes that we can use? But just kind of taking the decisions one step at a time as opposed to trying to bake them all together, which I think was one of your core points.
Because there's a higher level set of concepts that are necessary to make these exchanges, but we want to validate this level first. Like, you wouldn't want to think about components all the time. You'd want to maybe think about something else. We should just stay here.
I mean, I think in practice, given the current thinking, you do have to have a commit sort of concept, right? Because you're right, like if I delete my chair, I just delete it, doesn't matter. And everyone else just keeps using it. That's great. Now you have the cost of the share that doesn't exist in the model in one place, but does in another. Right? So there does need to be some concept of here is the source of truth. It's outside of every application, but there is a source of truth, right? It can't just be here's a bunch of things that have been created in different places and exist in some and don't in others, and this cost is based on version 5, right? So I do think that there does still need to be a source of truth. It's just outside of each of our individual applications.
Well, and that's a really important part. This absolutely shifts truth outside of individual applications, which is a big deal.
Per definition, I mean, I can understand you can put it outside of applications, but it doesn't.
Well, the second you have two,
Yeah, okay.
No, I mean, it does have to, right? If you can change if you can do something in this column, right? It can only happen in a consistent way if the column is not in my application already.
Required.
Right, we're
So, yeah,
looking
actually,
at the
yeah,
same
you're
column.
100% right, because this wall illustrates both sides not having the same information intentionally.
Does this also imply that the IFC is your source? Because if you, to your point, if your source of truth is not like equal, then it could very well be that you have two applications, two different types of source files that export the IFC. How did they sync the IDs?
So I would say it's either your source or there's a mapping to it. Anyways, I think in reality, Trimble and Autodesk and Bentley are not going to retool their stacks to use IFC files for their foundation.
No, I was trying to figure out if that even works then, because.
This is like this was in the context of design transfer. This is why this slide exists. So instead of what we try to do today, which is when you go from one application to another, you try to consume the data into your application. What this is implying is actually the reference is the way to make the connection to the other source of data. So it doesn't.
Right, but then you're saying that the ID of the entity lies still with the original source application.
External. So it exists here, not in there. So that's how this thing. Let's say you have a source application, you don't have any IFC data. The second this gets exported, the entity gets created and its components.
Yeah.
So now it's outside of this application, but exists.
Sure.
Right. And so now if you move here, this gets referenced. So the entity that's outside the other application gets referenced. You can make a link to that entity. If I want to add, change, move, I'm basically copying it, creating it, or mapping it to my internal representation, adding new information, and now I have the sum of both
But where is that then?
outside.
Yeah, where?
New cloud.
But that's an application as well, isn't it?
But it's out of one of these authoring applications. It's in a standard
okay.
format.
Okay, and not an authoring application like that, yeah.
Well, I mean, it would, no, I mean, that bottom left would sit in some data model that, yes, if you think of whatever controls the data model as an application, then that's the application, but the application is a data application as opposed to an authoring
Yeah,
application.
okay, yeah, but it becomes an authoring application more and more, because when you go back to the original idea from Trimble, where someone logs into Trimble Connect to add 5 properties as a fire engineer, just add properties to a door. For the fire engineer, then that is also an authoring application.
Well, the distinction though is Trimble wasn't republishing that data. They were adding it internally. This model implies publishing it outside of the authoring application.
So if I add properties in Trimble, all of a sudden I have to publish it somewhere else as well, because.
Well, you don't have to, but if you wanted to give it to somebody else, you do.
Yeah, okay, of course, yeah, okay, yeah.
Like if I'm an architect and I design a massing plan, all I have to do for you to start to take the next phase of detailed design is I just have to give you the GUID to link to start your work. That's exactly how I hand that to you is something that we have to tackle as a sub-problem for what's an effective workflow. But the general process is once I can give something a name, I can start to hook onto it. And that's all I really need to be able to do. It doesn't matter whether I'm literally storing it in the same place or in a different place because the merging is
That's if two applications have totally different workflows and not at all need each other's data except tied to the same GUI. But if you need like a geometry or something like that, you need to push it over the flow.
Yes, of course, right.
Right, and this also means we have to give like sub-element geometry potential QIDs, because then I can give you the base curve that you can build off of, instead of having to give you a full element. These are all things that come into play here, but that's the point.
Right, and that actually becomes both an archival format and a transport method. Right, it's the way that the Autodesk's internal thing and the Trimble internal thing can talk to each other via ISE.
Although the things have different versions, same GUID, but
Yeah,
I give
so-
you as a reference. However, when you give me back, you give me different value, like a placement. And then do I consider adopt your placement as a new version or reject your change?
That's not something the system could decide for you.
Yeah, reject or not reject, but certainly I need to tell you I have a new version of location. And I'm giving you a new version of location. I can't just give you location and you have to figure it out.
But the location schema could be different between two software. So how?
Well, that's why, like, if you,
Who's doing that? Like,
Okay. Just like IC today has a standard way of saying, here's how you define a point, right? We have to have a standard way of defining location. And location might not be the right term. It might be the XY location is a meaningful concept, and Z has a different owner. These are all possibilities of components, but they still have to be standard, just like we have to have, you know.
That's why it gets, and my presentation talks about this. So it's like, this is why it's kind of an exciting time is BSDD provides like the beginnings of what that would look like. You know,
Yeah, we're not going to use BSDD to define the standards.
but there are valuable lessons in what it's offering about each of these things. Here's its definition. Here's its globally unique URI. Any system that wants to transact can know it's talking about or requesting the same thing because it's uniquely addressed. And there's a standard way to go look up more information about it. That's all you need to. I mean, please challenge me on that. Like, that's all you need to be able to make this work. That I can, like, if I receive a component from you, it has a uniform resource identifier, and that if it follows some kind of standard protocol, you can figure out how to dereference it to go get more information.
That's all you need to visualize and to maybe show it to the user in some contextual way. But it's not the same as using it as an input to process.
How well? So if I receive a component that represents a two-dimensional polygon, and it has a single attribute that represents, you know, an array of points on it.
Sure.
And the definition of that is given a unique identifier that can be understood independent of the application.
Right.
Everything in that definition, any implementer, in the same way we do today, can write a piece of software that can parse and interpret in its own way what that polygonal loop is.
But if you're making a definition in the BSDD for a swimming pool, and
But this is like this is the problem. You never define a swimming pool.
Well, let's back up because there's a bigger problem, right? So I completely agree that on an individual level, what you just set aside, but you do need to have a collection, right? The point is, I have this in BSDD or whatever. That's not BSDD. We have this in
Web service that describe elements of components.
Right.
For end user.
and like I said, you can make it green or red. You can add stuff to it. Okay. You can also move it, right? But if you move it a meter this way, you're going to collapse. You're going to fly with the stats, right? So there does need to be this exists in a universe of other things, and there are things you can't do, right? In your system, you move it here. In my system, I added this desk, right? Those are incompatible things. Something somewhere has to say, sorry, you can't add the desk because that's moved, or you can't move that because this desk is here.
And everything described so far doesn't speak to how that particular problem is solved. This is just the first.
Completely agree. Yeah.
But I think it's because we are touching, if I understood correctly, we're touching on 3 different axes. It's good that we can mix them because I think they're all part of the solution, but at a certain point we might want to break them down to actually do the work. So I see data model, transportation and publication mechanism, which is actually should be facilitated by the data model. And this is where actually IFC now it's a little bit failing. So if you take the plug and play concept, or now in IFC, if you pull something, the whole IFC comes together. So the data model, transportation and publication mechanism, and then patterns or containers, because maybe we want to standardize the fact that you can associate a location to an entity and not location to a cost.
But so this is what we didn't want to get into, but this, you get these other concepts you have to put on top of any of these things to do exactly what you just said. And these components are fine, but I need somewhere to store it, a way to collect them together, give them some meaning and rules, and I need to aggregate them. These are other concepts that sit on top of it that we didn't really want to get into, or giving the timing, we wanted to just validate this first part, but they're absolutely necessary.
So, yeah, that's my understanding, at least from my summary. I don't know if it's a validation. So you have a data model, you have transportation / publication mechanism that should be facilitated by that, and then you have this pattern or collection to prevent that anything can be exchanged and an application doesn't know what to expect. So
Yeah, I mean, maybe this is.
Yeah, well, why don't we'll give it a try just before I do, but the thing about the model validation bit is really important. But at a certain point, in order to validate the correctness of any model or state, you have to capture it. And so that means that it doesn't mean you can do it at any point. It means that you've got to say, okay, we're going to check the status of is the desk and the movement of this pole in conflict right now. So you've got to aggregate the information, do joins and conflict merging, like you mentioned, a minute ago. And at that point, what you have is you have a full graph of relationships, because you have a bunch of entities that have components connected to them that have properties that, and the values of those properties may actually be linked back to other things. So at that point, you'd have to put a secondary layer on top of it to evaluate the kind of global state of everything. So just to reinforce that, this is just like the beginnings of the data model component. There are all of these other very valid kind of ecosystem support that has to exist on top of it.
The ISD file, would I have one for each discipline of that column? Or would I have conditional saying, I don't need an electrical because it's not there?
That's a question I have to do.
I think what we've said is, because you're breaking these down, you still need the ability to describe what, let's say you're the owner of it. I want all these things back. I want to describe the whole, no matter who authors individual components. So you should be absolutely be able to think about what does a complete column look like.
Right, it depends on who's interacting with that column, who's not.
Right. I mean, in other words, what you bring down to your application, you're going to bring down stuff that you care about. That doesn't invalidate the rest of it. Right. If you look, all you do is you're an electrical engineer that you place outlets. You just want to know that the column's a cylinder.
Yeah, I'm just going from the owner's perspective, and how I create the ISD file.
Oh, sorry.
To then have all these buckets. You're attaching all these buckets to the column, and then do I have one ISD for each electrical, structural, architecture?
So I think you have one.
So I have one, and then it's optional. So if there's no electrical on the pole, then I don't have to check that.
Yeah, I mean, look, practically speaking, if you have a standard in your organization of, if you have all these things, this is one IDS file for that thing. And if it doesn't apply, the same rules as exist today would be, if there's no electrical, I don't have to check for it, or it's not invalid. But I don't think that changes the conceptual relationship with this idea that different people are offering different pieces, but you as the requester can look across all of them and not have to think about them individually.
No, actually, you make an excellent point. I mean, if there's one IDS file, right? And I'm in Revit, right? And part of it is that the socket has to have some information, right? But I don't even have the socket in there. If the socket exists, it has some information, fine, but I have to have 4 sockets, it's gonna fail. Because I don't have any sockets.
But right, conceptually though, like this becomes a question of, well, what's the scope of your application? And if I can communicate my scope, I wouldn't check for sockets.
A single IDS file implies you're doing global validation at the root of like a work tree, right? I mean, and so to me, if you have one IDS file, implied is that validation starts at the root of whatever all of these systems have to be. As soon as you want to allow, what this model probably would imply is if you wanted to have smaller scopes, that IDS file would have to be kind of modularized so that smaller work groups could just test, are there just the 4 outlets that I need without having to have access to all the information. But if there is just one, then it would have to be done kind of by the owner's scope, which maybe is a reasonable assumption. But yeah, there is a trade-off we have to look at there.
Right, and to your question, I think for IDS 1.0, the answer is probably no, you would have separate IDS files then, right? This is the one that checks electrical stuff.
Well, it's a question of, it really just who's doing the validating. If it's at the authoring side of things, probably you have to split it up. If you have the collection of everybody's work and you can check it there, then it's just one.
Sure. Yeah, right. If you're doing it somewhere where you're going to have all the data, yes, there's one. But it may be conceptually that there's 4 different things to check. I have it also, I will check 4 things. Anyway, I mean, that's a detail.
Yeah,
But
I mean, we've never considered concept of ownership of, or scope or any of these things at IDS, so that's why this becomes a hard question. Leon?
Yeah, I was just looking at time, 45 minutes to go. You want Devon to speak as well, right?
And I'm gonna try to go. This discussion is way more valuable than my slides, so I'm gonna just try to kind of scan through some stuff and let's bite on what we want. And just as a kind of safe harbor, I do work for Schleusner, but I'm here as a community member and just somebody who cares about this. So this is just general, and I'm also representing the work of some others as well. So I'll go fairly quickly through this. So obviously we've been talking about what does the future of IFC look like, and one of the things I just wanted to call out, kind of what Greg alluded to, is that there's a whole bunch of stuff in the current IFC model. That how are we going to clean up properties? What do we do about math representations? All aspects of kind of incremental change of how we fix things that are in the schema today. That's not been the scope of our work. We've been working under this hypothesis that in order, the answers to some of these questions will actually be driven by the underlying data model and general structure of how these exchanges are going to work moving forward. So we instead were kind of looking at the domain agnostic requirements, like how do we support better, more flexible data composition across the stakeholder boundaries? And as we were alluding to a few minutes ago, there's been this growing discussion of these kind of ECS-like models. And by the way, the ECS thing is, from the video game industry, but it's really just compositional modeling. How do we begin to address the reality that we've got a bunch of stakeholders working across space and time to try to contribute to these assets that would need to survive many, many years. So that's where the focus of our work has been. We knew we had to, this can't remain a hypothetical armchair exercise. We actually have to try to find our way through this by doing some stuff. So we had a cohort together here. Here are some names of folks. As Greg knows, we meet in a lot of different forums. There's no substitute for meetings like this, which is just another chance to socialize with a wider group. So one of the first natural places to start here was trying to underpin all of our work on something that had a fairly solid theoretical foundation, and at least coming from my experience as a data architect, one of the core things is what is the underlying model we're going to use what are the nouns, what are the verbs, what are the relationships we're going to put between them. We haven't had a chance to sync up with Greg, so you'll see one of the things we have to work through is some basics of terminology, but there's a few things that have cropped up. So we have observed that at the core, if we think of the basic definition of things, we kept running into the same 2 to 3 different objects. One is at the most atomic level, there was this concept of a property. So this represents a single aspect or restriction on a set of values. What is the like an acoustic rating? Is it a string? Is it an integer? How many of them am I allowed to have? What's its lower and upper bound? What's its name in different languages? Everything you could kind of imagine. That's the absolute base of this definition, and it corresponds fairly closely to the definition you'd see in BSD. Then from the ECS model, we knew that these properties, their definitions tend to go together into functional groups, and we see this a lot in current IFC with p-sets. That if you have a Cartesian x, y, and z, that you may want to put these together into like a Cartesian 3D point. So this notion of a component with a many relationship to properties came up over and over again. That a component is a set of properties, and a property can be part of more than one component. That was kind of a key thing that we never diverted from. But then we kept having this gnarly problem that I'm really glad has been independently validated here. Is just because you can have a bunch of definitions of properties and you can attach them into these kind of sets called components doesn't really address this problem of global model validation and global model completeness. Sometimes I need to be able to say, you actually need these components to be able to call this a chair or a wall. And so for lacking better terminology, we kept running into this thing of what we're just calling here a type, which is effectively a set of components that when you put them together, you can give them a name so that when you tag something, this is a wall, that allows you to run validation to say, it should have all of these components and these components should have all of these properties. There was no way. Without this mechanism, we were struggling to find a way, exactly to the valid points that were brought up before, how we begin to do any kind of model validation. There was actually an alternative model that has been considered here, where this concept of type doesn't exist at all. Instead, components are purely composable. So if I have a component that has a property X and a property Y, I can compose it with another component that just has a property Z to make an XYZ component. So this creates a subsumption relationship among components. This simplifies the model in some way. It has a few really useful mathematical properties because they form partial orders, but it also complicates some of the implementation. So just calling out that this has been explored, but it was not immediately considered for some of the early prototypes. So the gist of what we sat on for the basic data model for most of our recent experiments has been exactly this, that there are properties that can have a many relationship to components, and components can have a many relationship to types. This is purely representing definitions. This model you see right here doesn't address instance data at all. It's just a point of departure. Yep, that's where I wanted to pause.
Can I ask what is the difference between a component and a property set? And what is the difference between a type and a class?
So that's actually right. The next slide was exactly that. And the more we got into it, we were not struggling. It was interesting to note that components, as we were seeing them in ECS systems and we were using them, were starting to just continually look more and more like property sets. So we actually leaned into that. The concept of a type, it does begin to really exhibit, similar structure. One of the differences, though, at least compared to traditional object-oriented systems, is that these are independent objects. So you can actually, unlike if you have a traditional property in a class-based system, that property will be owned by that class. This many-to-many relationship allows the same component to be reused across them.
Right, like fire rating should be in wall component
Right.
or component.
You are not having to use an inheritance structure. You can actually just link the property back to it, or you can link the component to the type. So otherwise they do fill similar roles, but it's kind of this reuse mechanism. It's imagine if you were to write like a weight bound, like object-oriented class-based system, it would work just like this. It's just that it's laid down so you can, you'd be able to have, these are independent objects in the runtime you could link to.
Technically, it could be classes and spaces.
Well, so there, that's one thing I'd love to riff on more, but the basic gist is you have a small meta model that describes properties, components, and types, and you can link them any way you want based upon, or you can link them in many relationships across the board. So this was at least as a point of departure, just to get us working with something, what we started with. Then one of the things that started to come up exactly to your point was, man, components really start to look like property sets. So what are we actually talking about here? And one of the things that occurred to us too is because so much of the community is already using IFC, man, wouldn't it be kind of interesting considering IFC P sets are in BSDD to start to use some of the BSDD data to bootstrap our thinking around this. So if you look at actually on the screen is the BSDD data model, and it's maybe a little hard to see in that case, but there's this concept of a classification, a property, and a classification property that links them. And this looks pretty darn similar to what we independently came up with. So that was just kind of an interesting note and a point of departure. So what we ended up building was we actually really liked where BSDD was going. We just wanted to change a few things. We wanted to be able to talk about implement this data model directly. We wanted to be able, in the current BSDD spec, at least in the API, these classification properties, what are components, are not first class. You have to look up something else and then fetch them. We wanted to make sure they were first class to make these many-to-many relationships work. And then one of the things we started thinking about too, to the points about how you aggregate and have stakeholders work on it, we're like, we're gonna, for the sake of experimenting, we're gonna make our own little system just to toy around with this idea. But what if there were different dictionaries that people had? How would we begin to do resolution across these to some of the questions that were brought up? So we did all of that, and we basically built a small little BSDD work-alike and began to explore these concepts. So you kind of see it called the BYO data dictionary stuff. So a small running example of that that's here is so this is just a little toy. Again, this is just a vehicle for experimentation, nothing else. But you can see there's been a bunch of properties that have been brought in. Some I have defined myself, so this is a dictionary I'm running. So imagine me as my own stakeholder or my own company. I've also got some that are being proxied to BSDD in the background. Everything has its own name, but it's also, and this is critical, it also has given its own unique identifier. So anywhere across any system, we know when we're talking about the same thing. These ones you see are the official buildingSMART URIs. And this is the current index of all properties, types, and components. So one of the things I can look at is I've actually defined my own definition of a SIP panel. The system is showing me it's just like in BSDD, its relationships to other components. So I can go ahead and take a look at an individual component like an energy value and check out its R value. So I can zoom in to see related properties. And then just like in BSDD, I can begin to get the metadata about that property. So this is purely definitional work. And one of the things that we're finding particularly useful is once you start to have definitions that have this amount of information on them, you can start to generate all kinds of output formats that people find useful. So basically leaning into what BSDD is already doing, like, yeah, it's great to get, the XML and RDF, but what if we could begin to get, a JSON schema definition for it? Well, that seemed to be possible. What if we could begin to get, for those who are using linked data, a SHAKL definition, and so on and so forth. So if we were to go look at it, we were able to generate even cases where, I'm generating once I know the schema of something, it's actually not that hard to generate a default instance so that people could actually use this to instantiate conforming instances kind of directly from the dictionary definition. And I'm fairly sure one of the next pieces of work would be, I don't know if anyone would want it, we could begin to put up express serializations of this. I'm targeting UML. I wanted to have it done for today, but it's not quite there. ISD, actually, it's silly. I don't know why I didn't think to add that in here. So that was one of the valuable pieces as well, to be able to add more and more serialization outputs for this dictionary format so that many different systems could consume it in the representation that they needed. One of the things that also came up, because we were talking about versioning in the dictionary as well, is this idea of automatic version control. So you can see that this particular component here that's tied to it has two different properties that are attached, but I can also link back to the last version when it only had one property. And because the meta model is the same across all of these things, we actually can determine automatically when there are breaking changes. So that was kind of encouraging. So the last thing I'll kind of show is not only what you just saw was the definition of a custom type component and a set of properties for something that I made, but all of the existing IFC definitions have been brought in as well. So here's the current definition of ISC wall. You can see its unique identifier. You can zero in on all the properties that are part of pset wall common. And of course, all the same serialization structure works. So rather than kind of loading it up on the screen where you won't get nice formatting, you can see here that I've got, I can actually get a nice view of what is a default instance, of IFC a pset wall common look like. What would a Shakel definition for linked data folks, if you wanted to use that, or if for systems that are using something like JSON schema, this allows you to do JSON-based validation directly off of the definition. So that was some early experiments we had in the actual implementation of this. And there were just a bunch of decisions that we were able to make. But the key point was that this concept of having a dictionary where you can begin to, that understands this data model natively, allows you to begin to do a bunch of things for coordination that you couldn't do before. So one of the things, and I don't know where to direct this, is this something that makes sense to, as enhancements to BSDD? Would it ever make sense to begin to standardize this data dictionary more as a cross vendor? I hesitate to say a standard because I know that there's some work against that. So I do want to make sure we understand why, because we are absolutely hearing, I would love to have this. I would love to have a dictionary, but sometimes I want to keep things to myself and I want to run them offline, or I need to run them in a data set, or I need to. And so the idea of a purely centralized, like a centralization is the only solution. We're just hearing other things from the market on. So I would like to come back to that.
Quick question. When you say support of property sets, do you mean literally this entity's version of a property set definition for other values?
I was just showing, that's one of the consequences. Once you know that a wall should have these components and each component should have these properties, generating a conforming instance with sensible defaults is trivial, because you have everything you need to do it. And so I was just demoing, that's kind of a nice fallout of this. You get ISD-like support for definitions of validation. So like in this case, a JSON schema validation system you could use for that. So you could also generate, I presume, and it would be nice to test this, an IDS directly from these definitions. And then because you know everything that's in the definition, you know how to generate the instance. So there's just a bunch of, if we begin to push the limits of what these dictionaries can do, there's all kinds of useful stuff that falls out of it.
But just to clarify, that is the benefit of the dictionary, not the benefit of this new IFC 5 standard.
But you're right. Those are two different things. So there's the benefit of this dictionary as a concept and as a services or service. And then specifically, this particular data model implemented as the foundation of this dictionary allows you to build these validation serializations automatically and build conforming instances from them.
You're saying that wouldn't work with a hierarchy base?
Well, you certainly could. I mean, you could implement it, but it would look like this. I think I would be curious if anyone can figure out without making each of these objects first class how it would look different from this. So I kind of given we're at the bottom. There is other area of work there in that we've now looked at how would you extend this to individual instances and kind of an instance model. Could the dictionary could the same basic structure of the dictionary begin to hold instance data? There's been a whole group of people looking at kind of in breaking out IFC and looking at modularizing it. How could we kind of like you have in Express the use import distinction? And how could we begin to use the dictionary to leverage that, including to capture components and disciplines that haven't been used before? And one of the interesting things that's come out of their work is kind of like Greg was alluding to, this concept that there are these other things that seem to be needed to the model. I see them called layers and scenes. They're calling them modules. So there's kind of interesting work to go on about how to reconcile. Are we talking about the same thing, or these higher level objects that get built off of these? And this concept of composition and reuse, which just keeps coming up over and over, is that I don't want to have to invent my own definition of location. This is what Leon was saying earlier. I don't have to invent my own definition of location if one already exists. So what's the mechanism to reference into that?
Can I, because I had a similar question on your elaboration on dictionaries earlier, because currently with the BSD, there's no real hierarchy, but because we treat the relationship to IFC special, there is some kind of hierarchy where you say you have IFC, then you have something that amends IFC, you could put a classification reference on top of an IFC entity, and you can do it multiple times. I'm not sure if what you're presenting on dictionaries here are you saying we should still have kind of the base layer IFC with then additional things on top of that? Or are you saying it is a whole network and I can put in a dictionary anything that I want, and then I'm going to select from the dictionary what I'm going to put in my IFC book?
So I would imagine it would be more of the latter, but imagine we only had one of these dictionaries and buildingSMART ran. It wouldn't be that different from the DSDB structure that's there now. You have properties, classification.
Yeah, but
properties,
my point is that when a user can just select anything they want from the dictionary and put that in an IFC file, we're coming back to what we said earlier on MVDs. As a software vendor, I want to support IFC, but if there's a lot of data that is coming in that I don't know, it's nice that I can look it up in a dictionary and have a human readable description of what it is, but then this.
When you get outside of property sets, you still have to give things proper names and give them like.
Yeah, but you need to standardize.
Yeah,
that.
so like the XYZ location with a rotation has to have a name and it has to have a concept that we say that's that kind of thing. And you can't make a new one unless.
And it's not just the name. ESD already.
Yeah, no, not the technology, just the concept.
Yeah.
What Greg is saying, we need to have a fixed standard set that we call these are the IFC entities. And then if you want to add something new, then how is that working how do you envision that in this situation? Anyone can just add additional things to it?
They could, but it's given a different URI. It has to.
Yeah, but then when I get a file, an IFC file, and I have things in there that I don't recognize, how do I know what to do with it?
Well, that's part of the contract. At that point, you're absolutely right. You're not doing IFC anymore. But remember, one of Greg's key points was that people are actively asking, we want to be able to include other standards as part of this.
Right. So that's why you can't assume that the only author of components is buildingSMART.
And so that's what that opens up.
Unicode.
Right. There's no mandate to it. You just have an identifier for any compatible IFC processing system. It understands the identifiers that are official, and all of the others, for the sake of that particular decoder, are out of scope.
So you're basically, it's similar as it is now. You can add your own classification reference to a proxy, just everyone that imports that supports IFC doesn't know what the proxies are.
Right. But
we're beating our heads into this GIS BIM working group, and like location as specified by Open Geospatial Consortium should be a component I can reference in my definition.
I understand. Thanks.
Right, but the key there being that there are certain things that we would explicitly, there's certain things we would say, we're never going to do this. Right? We're never going to do point clouds. There's one point cloud that can be a component.
Right, or that's somebody else's component completely. And if you, as a software vendor, want to propose, That's a good example.
Right, but I would imagine that, it would not be considered a success for, Revit's IC5 implementation to be wall, blob of binary Revit data. Right, like, there's still some.
It's certainly a supported use case of a component, because the first component you could have is a whole IFC file in a component.
And that also couldn't happen
Yeah.
because the way you first called wall has a URI that has to be the buildingSMART definition of a wall, which by requirement has these specific components and these relationships. So if you tried to, as soon as you tried to call it the buildingSMART definition of a wall, suddenly now you're bound to what that definition
So now
is.
you're saying that there is actually a mandatory list of components.
That's what this model in the dictionary in code is. I have, like when you saw in the Sama demo, I have this type, and here's its URI of the 4.3 IFC wall. These are the related components, and they're qualified that they're required under these circumstances, and then each of those has a set of properties.
Because in your example, there's a lot of optional components that you're adding, like a location was only added afterwards, or the color of the thing was added later. So these are optional components, obviously.
At the global level, but I don't know if others are finding it, but there are customers and deliverables where suddenly this thing that they've added is required. So this is where this idea of dictionaries being able to be extended or overridden somehow came into play.
This is a place where Devon and I converged, but didn't converge on language. I built this slide months ago, which just says my prototype wall or floor are these components. So this is an example of the same concept where you say this collection is a complete object, and I made the specific choice of saying for my project because this is the kind of flexibility we're being asked for. But the point of this is to say, I need all this stuff, not just the buildingSMART provided stuff. I have these other things that are required that some other organizations, that's what the dashes are supposed to indicate. But that's the complete thing.
Are the dashes just information, they're not model?
Well, no, it's just the idea that, on my project, I need a GSA mesh, which is a structural analysis thing, not a buildingSMART standard, but I need to include it. I mean, this is sort
Right,
of.
but that would be information.
Yeah.
That would use the model. Or the output of.
Oh, it would be other information that's part of the whole component.
And this is actually the very original thing that said, right? Because when I look at this, I think, right, because IFC is part of this ecosystem, it is not the ecosystem.
Correct.
Right, and that's where you started at. IFC is, here's how IFC would fit into it. Here's the IFC 4.3 definition of the wall. But in addition, I might have the unknown mesh associated with it, which would be beyond, not disallowed, but clearly not required.
There's no part of the IFC could validate all this other stuff.
No, that's fine. But the point is that the IFC 4.3 definition of a wall would go as part of an entity that is above any standard.
Yes.
Correct. That's why this.
Yeah, but, I mean, if you would be presenting this for OGC, you would probably have the OGC standard elements as a normal line, and the IFC things that you can add to it.
If I were to do this for a bridge and pick a bridge column, I would have two. One IFC geometry, one point, and one curve.
Yeah. So it's then you have an IFC standard that defines geometries and classes. But that doesn't have to be the starting point. You can also look at the data from the starting point of the GIS experts that starts with GIS geometry and location. And then from their perspective, it's IFC properties are being added to it.
That's why this becomes more of a transport structure than a container, or than the format.
Yeah, the branch in the first few slides about, that's where we're like careful to call out. This isn't just an incremental change of how do we fix staff representations. This is more about what are we observing how the work is changing and begin to make this stuff composable with each other. Because you see already even like the different standards coming out of Europe from the linked data community too. There's a lot of these like little nugget standards of just an ontology for doing, spatial decomposition, just one for MEP and plumbing. And in very niche markets, these things are being used. So if we, even just conceptually, if we wanted to, how could we allow that to enrich the stuff we've got going on as well? And
Is it like letting go of the utopian world where everything's standardized and everybody agrees with the same way of describing a location? Or is it fitting, I mean,
It's a multi-utopia strategy.
because let's be real, I mean, inheritance has its perks, I mean, if you design something kind of like a data structure and you only have to describe property once instead of having to regroup it in every single class that has this component, as you say, in there. I mean,
Well, so like every airport we ever work on does this. Like I work for HOK, big architecture firm. This is what every airport we ever work on does. This is what we need.
Well, and that's to your point, that I think there are standardized bits.
Right, they're substandards, not the whole.
What you've taken is the old class hierarchy.
Yeah.
And you said, here's what's an IFC element, right? Here's what it has. Now let me make the components out of that. Now when I make a nice product on top of that, or I forget what the ordering is now, I say use those components and have this component.
Yeah, so it's just shifting where we do the work of standardization so you can allow for multi-stakeholder standardization. Because right now we're sort of saying, the simple one that we have all the time is this: how do we convert an ISC wall into something in the GIS space? That's a nonsensical thing because they're both the same thing. This point in your GIS system and this column in a bridge are assigned. They're the same object with two representations. This is just adopting to that reality and saying, well, maybe this component doesn't store the data, it's just a URI that points to the system that holds the point. But it's part of that thing. So it is not giving up on standards, it is giving up on there's one standard to rule everything.
But to your point, it also doesn't preclude the kind of inheritance you're talking about. I turned it off at the last minute because it didn't align with other slides, but supporting a subsumption hierarchy on this stuff is not a big deal. So the idea that, in fact, and I'd love to have just a whole talk about the whole fact that I want to put a component next to another component and just reuse and inherit all the same things. That kind of support is just another line in the data model we have to say, and we already drew it in a few places. We're just going at light speed here. That there is this kind of many-to-many relationship between either components or types or some variant of them.
Well, and I took the furniture example and started to flesh out what these start to look exactly the same thing. They start to look like there's those chairs with single to many relationships. These are all nonsense because we want to get you to care about entities matter and not this is just Rachel's PowerPoints to have PowerPoint ready to talk about these things. But this is sort of structured. You start to you still have to do the same things, but is type a kind of relationship in this kind of model versus, and then can you decide which components are inherited versus like that crazy group type thing, you had to give this whole thing a name, and if you wanted to do something else, you had to get another name versus, well, no, I want geometry on each one to be unique, so I move it from here to here.
We clearly don't have time today, but one of the things I was hoping to come away with was we just put that quick picture of the data model on the screen was to have folks kind of take a look at it and, okay, do we need another line? Does this even make sense? Because there's so many things that derive from this that we can't move forward on in any depth without making a bunch of assumptions. So to your point, is there a many subsumption hierarchy that components need to support for efficiency's sake? That's something I'd love to understand.
right, and another thing that that comes to mind looking at this is that, like, if you're saying some of it is mandatory, some of it is not, that means that the component becomes an atomic entity where you can say whether or not that is mandatory. Which means that now, if there's certain workflows where some properties are mandatory but others are not, then they have to be in separate components.
And that's why each of these, at least as I'm understanding your question, all of those three things, at least as described, types, components, and properties, are independent objects, and the relationships between them can.
Okay, so a property can be in multiple.
Yes, if we got this, I lost my screen, but everything is, all three of them are many to many. So a component can have many properties, a property, and this is the property can be in many components, which is hopefully what begins to support the reuse of existing, like, use the IFC definition of acoustic rating, don't make up your own.
So that be true of quantities as well.
Correct. So just to, we're experimenting the same thing. We're experimenting on non-IFC rather than IHOK. So we're building, just testing this on all kinds of other instance data because we want to prove out it's valid in stuff we haven't seen before. So this is just a stupid prototype we built of a connect two things and build a relationship. And so we're doing things like starting with this stupid stuff big companies can't wrangle their connecting to building codes that we use, like a uses relationship with components and stuff like that. That's interesting. And then one other thing, just that these are all open source and we have a repo too, we'll maybe share.
Yeah, there's that.
So it's a whole other thing. Tom he worked on a ledger to support this kind of testing these ideas. So there's a whole bunch of experimentation going on right now. We haven't any time to go any more detail, but I think, I don't know, how do we get into it? Like, raise your hand if you think this is an awful idea. Let's start there. Like the base concept of using components.
Yeah, my big concern is I'm all in on the data model, and yeah, I think we can work out the details. This is my same issue with USD, by the way. I worry that we underestimate the business side of it. Keeping consistency, because I imagine, like in the real world, we have this wall. You know, have the Trimble secret sauce and the Revit secret sauce and Bentley secret sauce and everyone else's secret sauce, in addition to the parts that we say, here's the open part, right? And we try to make that as big as possible, so there's this little secret sauce that's needed. But in the end, if I change something in the open part, all of our secret sauces need to change. And that might say, okay, now this model is no longer valid, right? In Revit, if I move that wall, these two walls are going to change. In other systems, they're not, because you don't have that. So if someone else moves this wall, I need to be able to, something needs to go tell Revit, hey, modify these walls, and then figure out that they violated the length of the wall is no greater than 20 feet rule. So you can't do that.
You have begun to talk about the the ECS model, which is a service that, and it's an open question with buildingSMART ever touches any of those things, or this is a consequence of using these models. You can write this a very small service to do exactly that, because you have very granular data sets to check small things. So, yeah.
And I'm just worried for a lot of these initiatives that there's a concept of, we'll worry about that later, when actually that might fundamentally change some of the structures, thinking about that.
Do you have another 2 days?
Another week.
Yeah, this is, we wait 5 minutes to go or something. What are the next steps?
So we think, I have a list of what we have to work on, but I think this is my estimation of what we could show in the short term, because there's a whole, like we haven't talked about how you transport these things across the web and all this stuff. But I think we could make a prototype taking existing IFC data on the instance side because we've already started about the management side. I think this is where we start. We have enough work on the instance side to make a SQLite representation of this model. I think this is a good start because actually people build tooling around this, like XBit, and this sort of stuff. So I think this isn't work yet, this is just evaluation. I think at least my estimation is on the instance side, we do one of these. It's not satisfying, but it at least makes something tangible.
It depends on which use case you take. Because if you want to do this for IFC alignments, it would be very interesting actually. If you do it for walls and windows again. Yeah, probably.
But so if somebody wants to say which one of these should we model in sort of an instance data, and we pick one, I'm all for that.
Yeah, I'm most worried about everything that needs to be placed along something, the grids and alignments. Placement is the big black box for me in this concept.
Well, this is where, like, going back to we start to say there's unified concepts of placement. That's one thing we have to address. And
Yes.
like, there's 10 kinds of location in IFC today, and they're not all in the same spot.
Pick one.
Right. So if we want to pick linear referencing, we could absolutely do that.
Yeah, but there's a really nice use case, I think, coming from the real project where they have an alignment geometry with the idea that one person controls the alignment geometry and there's multiple persons that want to link to that. So I think Ivandro can explain a bit on that use case as well. But this is currently not possible with IFC. I think it would be wonderful. It is possible with DIX. This is a concrete example coming from industry with one lit, and it's not possible with Q and IFC, and it is possible with ECS.
When you can actually subdivide vertical and horizontal in this model, because you could have a vertical location and horizontal location.
Yeah, but there's a lot more to the different alignment geometries. There's business logic and there's geometry. I think that would be, if you can have that. I mean, there's a lot more as well. I can give you a list, but this one is on top of my list. But open to other suggestions as well, of course.
At least from my perspective, if there is still interest in pursuing this, just as a gut check, to me, I wouldn't want to go much further without nailing down, okay, fundamentally, this is a class instance-based system and it uses this basic meta model as its foundation. I would feel like I've wasted a lot, I wouldn't feel comfortable pursuing much further without these assumptions, and that requires community validation. How would we go about that?
You should start to ask the
Make a list of assumptions or best guess by now. Do a prototype and see how many of them can actually validate and how many fail. I don't know. Just listen.
We have the same, because I think I can write down a bunch of assumptions on instance data, right? You can, so I think we're at the white paper stage plus sample data.
Because you also have the ambition for Rome to kind of scope out something.
When Rome, this is a less technical discussion. We just want to get the assumptions that we're designing for reiterated.
But they're very similar to confirmation types.
Yeah. We just don't want to have to describe like the data model of it is these that we use.
Why not?
Well, if we're talking to ourselves, but if we're asking the building room.
Everyone in the technical room in Rome is the same as here.
Oh, no, if we're asking the building room and the infra room.
Yeah, you should. I wouldn't do that.
You actually told us we needed to do this in Montreal. You need to put this in front of the other rooms so they can agree.
Yeah, but not the domain experts of those rooms. I mean,
yes.
Yeah.
I mean, it'll scare the living bejesus out of people.
Well, this is why, what I said we need to do is go through that. This is what we heard we need to solve section.
Yeah.
Not all it's solved.
what I have problems with is that this, in effect, very powerful data model makes us more flexible and able to support more things, right? Which has always been, I feel like the effort level has always been like, okay, IFC can now support more things. The problem is that that doesn't make it more standardized. It makes it less standardized. We have to define how we're going to make these standards work for these specific workflows that we're working with for a specific industry.
So I would only say that the commentary is we tend to standardize the whole, not the exact pieces. And this gives us the opportunity to standardize just the pieces that are necessary for the workflow.
So I know that you think that if you no longer have those constraints of the hierarchy and all that stuff, that standardization will be easier. I'm afraid as a vendor that standardization will go out the window and you're going to standardize everything for every single small project that you have, everything.
Well, so I mean, we've had this discussion forever that the way you should standardize IFC is unit tests.
No, you have two different topics you're talking about.
Well, I agree with you in the sense that we are technical people, so we come up with solutions and then figure out the problems with those solutions. We do need to be very explicit. The very first thing has to be very explicit about what are the problems we're trying to solve. And in my mind, one of the problems we want to have is more standardization. Yes. And we want to reduce the amount of time it takes to create a new standard. Yes. Right?
But we also want to support a couple of additional use cases or user workflows that can't be supported now.
And then that's it. And we want to expand the scope of what we support without necessarily, like, that's the, how can we use GIS, right? Without.
No, that's the use case of, I have an alignment here and others need to use that alignment in other files without having to copy it every time.
Okay, so I want to improve reference workflows.
But it's a distributed ownership problem.
Distributed ownership problem.
Right, but I mean, making those, because once you see those explicit questions, then you can look at the technology and say, I see how this solved that problem or not.
Right. Yeah, and I think this is addressing the third problem that you brought up, not the first two, where not the standardization.
Yeah.
And I feel like I worry. That's all. I don't think I fully understand it anyway, but like
maybe over dinner or more coffee at some point. But like, there's nothing, and probably not more coffee. There's nothing in this proposal, at least that I've seen. We had that great conversation earlier about the stair container, right? There's nothing in this that, in my mind, but let's test it, would preclude. There's one way to make a stair, because a stair container has a single canonical definition in the dictionary that resolves to only one dictionary entry. It has these components that have these properties. This is what's required. This is what's optional. That is the definition. In the same way that when I open Oxford, there is no, this is what I get when I look it up.
Yeah, I think there's other problems that need more standardization, not how a standard is proposed, but I mean, there's 3 different ways to add color to an object now. They're not even spelled the same way. 5 different ways to add materials.
Yeah,
That's the parts that,
those are the
like changing the technology on how we're going to change the data doesn't solve the fact that we still have a lot of these ambiguity in ours. So there's 2 problems that both need to be solved, but I agree with your analysis that currently it's mainly focused on these new workflows, which is good. Because the other things still needs to be done anyway.
Well, that's not a separate problem.
Yeah, no, you have to have a new framework to solve these problems. Otherwise, I think the way to characterize it is we need to sort of describe a system that can solve the future problems and also address these old problems. But unless we have a direction, we can't solve the old problems.
Yeah, we're saying the same.
Here's the
Even if
component
we're
that
not
describes
doing,
color.
sorry?
Here's the component that describes color. This is the component.
Exactly.
you're not allowed to make a new component that describes color.
Or if it is,
But
it's not
that's
the
an
same.
important lesson right there. Like, otherwise, users will make their own component for their own specific color.
But if you make your my color component, we can't stop you, but no one's going to support that.
Right, well, guess what? There's gonna be some states that band together to start making new components for their specific way of working.
It's exactly what they're doing with properties now.
Right.
Actually, even to define color, because it is so badly defined in IFC.
Right. So I'm saying standardization is not just giving them one way of doing things, it's also saying, no, you can't make your own way of doing that. This is the way to go.
I don't know how to do the second one.
No, and this is going away from that second.
No.
Right
Because
now, I
actually-
can create a key set, my perfect
But
color.
you have a class structure and you have to somehow, it's kind of implied that you adhere to that class.
Right, but the
still
class
have
structure
that-
doesn't do that.
We still
for us.
have that in the new system as well. You still have the lines that are part of the IFC standards. You can just add point clouds or objects to it as well that are part of our standards. But we still have the defined set of classes that has a specialization structure and that is published somewhere as an ISO standard. That's not going away.